Hello, welcome back to CSC 263 Database Management Systems at Adelphi University. In this video, we'll start introducing the Structured Query Language, or SQL. So, up till now, we have talked about databases in abstract terms or in conceptual terms. We've introduced the relational database model, that basically says how we divide up our data in relations, in attributes, and in tuples. And then we talked about how we can take those relations and analyze them, and even, if necessary, convert them to minimize redundancy so that we can ensure data integrity. What we haven't done yet is actually show you how to do this on a computer. And so that's what we're starting with now. After having seen all of the theoretical approaches to data, including the relational algebra, this should come fairly easy. The language that we typically use to interact with relational databases is called SQL or SQL, the Structured Query Language. It's a different language than what you're used to. Up till now, in terms of computer programming, you have probably seen languages like Python and Java. Maybe you've already dipped your toe into C or C++, or maybe even some command line shell scripting. What all of those languages have in common is that they are procedural languages. In other words, it is you telling the computer step by step how to do what you want it to do, how to obtain input, what to do to those input, and how to create output. SQL is a different language. SQL is based on the concept of show me what the output should look like and let the computer figure out how to get that output for you. We call that a declarative language. It means that we describe what we would the database to look like or what we want to get from the database, but we let the database management system figure out how to actually orchestrate that. So it's a different way of thinking. We're not going to go step by step. For example, you won't see instructions that say, open this file and from this file read line by line. What we're going to be doing instead is, connect to a database and execute a query. And that's all we do. When you've seen programming languages before, what you'll see in most of them is that the programming language is case sensitive. In other words, especially when it comes down to variable names or function names, case matters. That's not the case in SQL. At least not in the SQL version that we are using. The language statements themselves are case insensitive, which means that you can write them however you want. It also means that you can span multiple lines for a query, and we'll see how I do that to improve the readability of my queries. Footnote though, strings text stored in the database is case sensitive. So if you're dealing with trying to match, for example, someone by last name, at that point the last name is a case sensitive match. SQL doesn't care about whitespace, including new lines, as long as you start your statement and in many cases end the statement with a semicolon, you're good to go. And again, I'll show you that as we start looking at code examples. Now, one thing to keep in mind is that each database management system probably has a slightly different version of the language of SQL. There is no such thing as a standard SQL that works everywhere. What does exist is a minimum feature set that pretty much all modern SQLs have in common. And that is what we will be focusing on in this class. We're not going to use any of the product-specific extensions that are provided by a given database management systems. The types of queries that we will write and that we will explore will work on any reasonably modern relational database management systems, even though there might be sometimes more intuitive and smarter ways to do things. We might not introduce it here because it is not part of that standard feature set. That standardized feature set is also known as NC-SQL. There are different versions of that, but don't worry about that too much. So again, we're trying to use the minimum feature set, the maximum compatibility as a result of that. The language itself, the SQL language, is divided into two sub-languages. One is called the data definition language, the other one is called the data manipulation language. The data definition language manipulates the database schema, in other words, the metadata associated with your database, while the data manipulation language manipulates the data that's stored in the schema. Both of them support these CRUD operations. CRUD is a shorthand for create, retrieve, update, and delete. So with the data definition language, we have statements that can create, for example, new tables, delete tables, update tables, or figure out what tables we have. We can do the same thing with actual tuples themselves. As I mentioned before, for our class, we'll be using a database known as PostgreSQL or Postgres. That is a free and open source implementation of an object relational database management system. We are not going to use the object part, we are going to use the relational part. You can download Postgres and install it on your own computer. It will work just fine. As we start dealing with Postgres and its command line interface PSQL, keep in mind that there is no such thing as an "are you sure" prompt. So when you tell it to delete the contents of your database, it will delete the contents of your database. If you tell it to remove your database altogether, it will do that happily for you without prompting for confirmation and without for having a undo option. So be warned. Let's take a quick look at the architecture of the lab on the slide behind me. Somewhat complex if you look at the slide. In practice, it's not going to be that difficult, but it's a good thing for you to know how everything fits together. You as the end user are all the way on the right. You are an individual who is using a computer. The computer is the first rectangle from the right that you'll see. And on that computer, the only thing you need to have is a secure shell client. Whether you're on a Mac or a PC, it doesn't really matter. And there's a wide range of choices that you can choose from. Whether you use an SSH client on the command line, on a Windows command prompt in PowerShell, on a Windows command prompt in a Bash, in a Linux box, in a Mac, it doesn't matter. Just type SSH space and then follow with the rest of the information and it will work. If you would rather have a graphical user interface to do all of this, again, those are widely available as well. The most commonly known is called PuTTY, P-U-T-T-Y. It is primarily a Windows-based system. It works very well. It's free open source software. You can just grab it and download it very easily. If you want to have something slightly more advanced, you can look at something called Termius, but they all work the same way. They all implement the basic SSH protocol. You use the client to connect up to the server. In this case, it's the computer science server at Adelphi University. Note that it's IP restricted to only allow incoming connections from a US-based IP address. If that does not work for you, let me know and I'll help you out. As you connect to the SSH daemon, the SSH daemon authenticates you. After authentication, it will spawn off a command shell, typically bash. And from that command shell, you can issue additional commands. One of those commands can be PSQL. PSQL is the frontline command line interface to the database management system. You don't interact with the DBMS directly. You do that through the monitor application, or in this case, PSQL. Once you launch that, the PSQL application will connect to your database and you can start typing SQL commands and SQL queries, and PSQL will pass those over to the relational database management system, and it will pass back whatever response the DBMS generates. The DBMS will manipulate the actual data on disk, so it's stored in the database. You'll never touch those. You can look at it. It's stored on the file system. You probably won't be able to read those files because of file system permissions, but you can see that they are there and look at them and change them, for example, by looking at size or date. So that's basically it. You're going to connect to the SSH daemon with an SSH client on your computer. Then within the, once you've connected, you issue the command PSQL, all lowercase characters. That will connect you to the database, and in the database you will execute your commands. As we start talking about the different constructs in the language, I will show you how to do those so you can follow along rather easily. I am using the same setup to record that as I am here.